Okay, third lesson of the chapter, and we're already going to stop and just review what we know. Things you should be able to do at this point, but take a look at this question mark. Right there at the end of things you should be able to do at this point. Most of this lesson is things you should be able to do. Maybe all of it is, but there's a couple of things that maybe we haven't taught explicitly. The weapons are there. We've got the mathematical tools we need to do those problems, but maybe we haven't put them together like this yet. So it's really tying a bunch of stuff together. Okay, first part of the lesson, stuff you should know at this point. And if you don't, watch this part of the video very carefully and watch it again if any of it's confusing, because this is stuff from last chapter and from the first two sections of this chapter that should be pretty straightforward. It asks, on the axis below, draw the graph of each of the following lines. The first one is y equals 5. You have to get to the point where when you see y equals 5, you immediately know what we're talking about. Y equals 5 is a horizontal line. It doesn't have a slope because there's no mx term here, and it goes through y value 5, so it's right straight across right there. There it is, y equals 5. I'm going to label it on there. When you're doing more than one line on a grid, definitely label them as they go. And for this lesson, because I've got colors available, I'm going to switch colors too. So that one was in a nice black type color, so now I'll switch over to a nice pink type color. Next one. X equals -4. When you see x equals -4, you have to get to the point where your brain gets triggered and goes, oh, that doesn't look like y equals mx plus b. It's not like the other lines. It's a vertical line. Where is the vertical line? At the x value of -4, right there. So, in some ways, graphing these special lines is easier because it's really straightforward. You don't have to think it through too much. Once you know what kind of line you're doing, you just write it down. But it's also harder at the same time because you have to have the knowledge. You have to know what those things are. So even if you make some cue cards up or something like that to study these things, to make sure you know exactly what you're looking for when you see vertical and horizontal lines. I'll switch to green for y equals -2/3 x. And y equals -2/3 x, that doesn't mean there's no y-intercept. It means the y-intercept was 0, so we're starting at 0, and then we're going down to, for every time we go over 3. So there's the y-intercept of 0, down to over 3, down to over 3, down to over 3. And, if you're doing this, again, I've said this before, by the time you got about 3 points, that's more than enough to draw the line when you've got a ruler available. I don't have a ruler available, and the straight line tool in here is a little bit wonky, so I've got to do it this way and get a lot of points on there to try and help me. So just bear with me as I get a bunch of points on there. And then once I have a bunch of points, I think I can sort of hold myself straight there. A little wonky on that one. I'm going to label that y equals -2/3 x. I'm going to try and slide one more on that grid. I've provided 2 grids here. What color? Maybe a purple will look different enough. The last one, y equals x, that's a very weird one, y equals x, because at first glance you're like, well, it looks really simple, except I don't know what to draw because I don't see any numbers there. So you have to know enough to go, oh, what this means is y equals 1x. That gives me the slope I need. And again, this one had no y-intercept, so it's going through the origin. It has y-intercept of 0. So I just said that. It has no y-intercept. That's not true. It has y-intercept of 0. Only vertical lines have no y-intercept. So this one starts at 0 and goes up by 1s. So going up by 1s is a nice, easy thing to do. Excuse me. Okay, so y equals x. I did all 4 of those on that grid. Getting pretty jammed up, so I'm going to switch over to the other grid for the other ones. I can stick with my purple here. This one here, y equals -x, so we're really talking about -1x plus 0. It has a y-intercept of 0, but it's going down by 1s. That, and again, I intend to put 3 lines on this grid. So I'm going to label these carefully. There's y equals -x. Next one, y equals 4x minus 8. So this one, I need to have a y-intercept of negative 8. And the slope is 4. For clarity of thought here, I'm going to put that as 4 over 1. Because it really helps to think about what the slope is. It's got rise over run now. Rise 4, run 1. 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 And then one backwards point like that. Ooh, I went in purple there. Let me switch over. The dots are purple, but I'll switch over to a green color so you can really see which one I'm working on there. There's y equals 4x minus 8. All right, now this last one's interesting. We did this line 2 different ways last chapter. We could do it with x and y intercepts. That's a great way to do it because if I set the x to 0, I could get the y value of negative 4. This would be negative 5y equals 20, y equals negative 4. I could get the x-intercept. By setting the y to 0, I'd get 2x equals 20, x equals 10. And what a great way to graph this line. I'll switch over to black this time. Y-intercept negative 4, x-intercept 10. And just like that, I can graph the line because I've got the 2 points I need. A little harder for me on the screen like this, but I can do it. Now, if that's not what occurred to you, if when you saw that, you were like, oh, well, I'm just going to rearrange it to y equals mx plus b. You could totally do that too. You could go negative 5y equals negative 2x plus 20, divide everything by negative 5, get 2/5 x minus 4, and then you could just graph the line. You get the same line. So both procedures are good. I'm not saying one's better than the other, but when the x and y-intercept thing works, well, it's really fast. Whereas solving for y equals mx plus b can take a little bit longer. That's fine. Okay, that's mostly a review of the first lesson of this chapter and things from last chapter. Then the second lesson of this chapter talked about parallel and perpendicular lines. And so now we're going to review some of that. It says write the equation of a line that is parallel to y equals negative 6x minus 8, but lower. When we say parallel, we want to have the same slope. That was one of the big things that came out of last day's lesson. So the equation I'm going to write has to be negative 6x because it's got to have the same slope. Now, when they say lower, I've got lots of choices. I've got lots of available answers. There's some wrong answers. I can't use anything higher than negative 8. So anything lower than negative 8 is going to work here for lower. So I'm going to go negative 20 just to exaggerate that I see that it's lower. The other big thing that came out of yesterday's lesson was perpendicular lines. And so if we want perpendicular to this, we want to do the negative reciprocal. We've got to flip the slope and change its sign. So I've got to go that. Flipped the slope and changed it from positive to negative. If it had been negative, I would have switched to positive. But this says with the same y-intercept, so I've got to keep that y-intercept that they gave right there. I don't have my choice this time. Some of those questions sort of give you a choice. This question doesn't really give you a choice. All right, so now, this is the part of the lesson I was talking about that we sort of have showed you these things, but maybe haven't made it really explicit what you're supposed to do in these situations. And that's why we sort of pause for a review lesson to make sure that the things we've shown you over the different chapters, you can use them here. It says determine if the point 6, negative 3 lies on the line y equals 2/3 x minus 7. So one way to do this, there's several ways to do it, but one good way to do it would be to just sub in x equals 6 into y equals 2/3 x minus 7. I'm going to sub in x equals 6 and find the y value that goes with it. If that y value happens to be negative 3, I'll know 6, negative 3 lies on the line. If it's not the right y value, well, then 6, negative 3 is not on the line. So here I go. Y equals 2/3 times 6 minus 7. And just to show all the steps here, I'm going to think of 6 as 6 over 1. And then I'm going to do my multiplying fractions, top times top, bottom times bottom. Simplify that. 12 divided by 3 is 4. And 4 minus 7 is negative 3, which is the y value I wanted. Yes, it worked out. That is the right y value. Yes. 6, negative 3 is on the line. So that's one way to do it, is when they're asking you if a point's on the line, just put the x value in and see if you get the right y value. That's a great way to handle it. Here's another one. Determine if the point 1, negative 1, 3 lies on the line. So let me just propose another way to do these type of questions, which is a little left side, right side check. And we use short forms for left side and right side. We use LS and RS. We use them so much in math that people get used of LS and RS for left side and right side. So what we do to check if this point is on the line is we just write 4x plus 5y on one side and negative 10 on the other. And when we sub in the x and y, this equation better work. It really is very similar to what I just showed a second ago, but it's just a different way of handling the setup. So then I can sub in both the numbers here. 4 times the x value that they want to check is negative 1. 5 times the y value they want to check, which is 3. And I get negative 4 plus 15. Whoops. Negative 4 plus 15. I said the right number, but wrote the wrong number. And I got 11. Oh, this does not check out. No. This point is not on the line. Both equations really are about substitution and about checking if the value comes out right. But they really have a slight difference in the fact that the right-hand side example was one where I was using a equation checking method, whereas the left side I was just finding the answer and seeing if it was the right answer. And so they're slightly different methods, but both are good. Okay, last question of the day. They first define collinear points. They say points are collinear if they're on the same line. And then the question is, how could we determine if 3 points are collinear? Well, this needs a little explanation here. I'm just going to draw a little diagram here. Let's say I've got 3 points that aren't collinear. So I've drawn a line through these two and said, okay, here's a third point that is not on the line. For that to be true, this slope and this slope would have to be different. If they're on the same line, the slopes will be the same. So think of a line where 3 points are all on the same line. Then we'd get the same slope here, the same slope to here. We'd always get the same slope if they're on the same line. So how can we determine if 3 points are collinear? Check if the slopes between points are the same. That's our method. And I'm going to give that the highlighter because that's maybe the only really super new thing in this whole lesson. If you're making up a study page, that'd be a good thing to put on your study page from today's lesson. So it asks, determine if the point P, Q, and R are collinear. Here's how I do that. First, I find the slope between P and Q. And this is a great way, when there's a lot of different points going on here, a great way to handle finding slope between 2 points is actually put the letters of the 2 points that you're going to find the slope between. And I'm going to use this slope equation from last chapter, y2 minus y1 over x2 minus x1. Hopefully this is old hat by now, but if it's not, here's a quick review. The first point, you call them x1 and y1. And then the second point, you call them x2 and y2. And you just sub into this equation. You go 6 minus 12. Over 3 minus negative 6. Careful with negatives. That's the one thing that can mess you up with the slope formula here is when you have negatives, you've got to sub in there. You got to be a little careful there. And I get negative 6 over 9. Now, I'm missing a step here. And if your brain's just blasting at that and going, yo, you got to fix that. Yeah, I know. I'm going to fix that. And I'm going to reduce that fraction down to negative 2/3. It's such an important step now because we're going to be comparing slopes. We've got to reduce the fraction. If we're going to compare two things, we better make sure they're both in reduced form. Okay, that's the slope between P and Q. Then I'm going to find the slope between the next 2 points, which is Q and R. And I'm going to do this in green, just to really establish the difference, but also because I want to relabel these points. Now I'm going to call this one x1, y1, and this one x2, y2. And so here comes my formula, y2 minus y1 over x2 minus x1. So I get 0 minus 6 over 12 minus 3. and I get negative 6 over 9, which is negative 2/3. See, by making sure I reduce them, if they had to come out to be slightly different fractions, the reducing makes sure that I know whether they're equal or not. Therefore, the slopes are the same. Therefore, all 3 points are what we call collinear. They all lie on the same line. That is a great algebraic way to do it. You can do it with graph paper, but the problem is you might not know exactly. It might look like it's close, and you go, yeah, it sure looks like they're on the same line, but when you do it algebraically, you prove it exactly because you get exactly the right slopes here. So, is that new, that last example? Well, yeah, it is sort of. Like, we haven't really talked about an example like that before, but it's using all the same weapons that we've already used in class, which is finding slopes. And the same here, subbing in and doing left side, right side checks. Those are all things we've done in other sections, but we're just using them a different way here. So that's all you have today, is just a few review questions to make sure that you have all that stuff ready to go, because things do heat up in the next few lessons and get a little tougher. So we want to make sure all this stuff is very clear before we move on. All right?